As I've mentioned before, one of the goals of object-oriented programming is code reuse, and one of the ways that we can reuse code is through inheritance. Inheritance is a wonderful thing, and we should use inheritance, but there are times when we can take inheritance to the extreme. Let's look at the example from lesson 4. We have the beverage data type, and then we have the coffee data type that inherits from beverage. Now this design isn't the best, but it is simple, and as long as it stays this simple, then I'm okay with this code. But let's say that we wanted to accommodate other people, because other people like their coffee in different ways. I personally like my coffee black, but other people like to add sugar, others like to add creamer, some like to add flavoring, and then there are those that like to add all three of the things. We can implement the idea of additives in a variety of different ways. One of those is with inheritance. So for example, we have our coffee data type, but we could have a data type called coffee with sugar, another one called coffee with creamer, and then coffee with flavoring. But then we would need to incorporate data types with multiple additives. So then we could have coffee with sugar and flavoring, coffee with creamer and flavoring, and so on and so forth. And if we needed to add more additives, then we would write more data types. And you can quickly see that we end up with a ton of data types. And these data types don't really vary in functionality. They all have the same functionality. There's just tiny little differences between the different data types. And if you find yourself in this particular situation, then you need to rethink your implementation because it's obviously not working very well. And that's where the decorator pattern comes into play. A decorator is basically a wrapper, and it's used to extend the functionality of an object while maintaining that object's interface. And because it is a wrapper, we can implement a decorator in a variety of different ways. We're going to first look at a very simple implementation, where we take a coffee object and we decorate it with different things like the size of the coffee, or some additives that we would add to the coffee. And the easiest way to wrap an object is to simply pass it to another function. So let's create a function called small to represent a small coffee. This is going to accept a coffee object, and then inside of this function, we are going to take this coffee object and modify the cost. The default cost of a coffee is 5. And we could say that the default size is medium. So for a medium function, we would leave the cost alone. But for a small, we would need to subtract something from 5. The first thing we want to get is the current cost of our supplied coffee object. So we will call the cost method and then set that to the cost variable. And then we are going to set a new cost method on our coffee object because we don't want to change the interface, but we do want to provide more functionality. And inside of this new cost method, we are going to take the value of cost, but we do need to return this, and then this is a small method, so we are going to subtract 1 from it. The idea being that a small is $1 less than a medium. And one other thing that we should do is, instead of making this a standalone function, we should go ahead and set this as a method on the coffee function object. The idea being that from a code perspective, this small function is meaningless, but attached to our coffee function object, then we know that this is a small coffee, or it's used for small coffees. And now we can take this same basic idea and we can apply it to basically everything else. So we have a small method, let's have a medium method, and a large method. Now the medium is the default, so this medium method really isn't going to do anything. In fact, it's going to be an empty function, so we can have that just on one line. And then let's create our large method. And instead of subtracting 1, we will add 1 to the cost. And then we could take this same basic idea and apply it to things that we would add to coffee, like sugar and creamer and whipped cream and things like that. You know, things that are usually free, but for the purpose of this exercise, we will make them not free. So let's create one for sugar, because some people like sugar in their coffee, and $1 is kind of too much. So we could set this to 15 cents. And really, we can make this the base cost of all of the extra additive stuff. So we can copy this method, we can paste it in and change this to creamer. Then we can add a method for whipped cream. And we can even take this same basic idea and apply it to other types of drinks like a mocha or hot chocolate. But hot chocolate really doesn't work because that's not coffee based. So let's make this whipped cream. And then I'm going to paste in some methods. One for milk, another for foam, and another for chocolate, because we are going to use these for a mocha method. Now I know technically mocha is espresso, but for the sake of simplicity, we're going to stick with coffee. Now this method is going to be a little bit different because this is going to use some of the other decorators. Specifically, it's going to use milk, foam, and chocolate. So instead of getting the current cost, all we need to do is start off by creating our new cost method, and then inside of this, we are going to call those functions. So coffee.milk, and then we will pass in our coffee object. Next, we'll call the foam method, once again, passing in our coffee object. And then finally, we will call the chocolate method. So coffee.chocolate. This is going to accumulate the necessary cost for these different pieces of a mocha. And then finally, we want to return coffeeobj.cost. Although, no, we don't, because we can't call this method inside of the method itself, because that's going to get us into trouble. So instead of doing all of this inside of the cost method, let's put it outside of the cost method. So we will call milk, foam, and chocolate, and then we can create a variable to store the cost, and then we will return the cost for that method. And before we test this in the browser, let's go ahead and create another object. We will call it mocha, and we will new up coffee. So let's head over to the browser, and let's say that we want to create a large coffee with whipped cream. So we will do coffee.large and then pass in our coffee object. Then we want to add whipped cream. So coffee.whipped cream, we'll pass in coffee, and that will add the cost for whipped cream. So large adds 1, and whipped cream adds 0.15. So we should end up with 6.15. So let's call coffee.cost, and that's what we get, 6.15. Now let's do our mocha, and let's create a medium mocha. Now I know medium is the default, but we still kind of want to call the medium method, because while it's the default now, that doesn't necessarily mean that it won't be the default later on. So if we are always specific in what size we are creating whenever we create these objects, then we won't ever run into an issue if we do change the default size. So coffee.medium, we'll pass in our mocha object, and then we want to make it a mocha. So coffee.mocha, and then pass in mocha. The milk, the foam, and the chocolate are each 15 cents. So by calling mocha.cost, we should get $5.45. And we do, except for a few zeros and then a 1. And that's because we are dealing with floating point numbers as opposed to accurate decimal numbers. There is a difference between floating point and decimal, and hopefully sometime we will see that difference in JavaScript. So even with these very simple decorators, we were able to add extra functionality to our objects without having to write a data type for every possible combination of coffee, size, and things to add to the coffee. Now there's something that bothers me about this particular implementation, and that is we have to do two things in every one of these methods. That is, we first of all have to retrieve the current cost of our coffee, then we have to create a new cost method on our coffee object. And while this particular solution works, we could get around of all of this repetition by using inheritance and the prototype. So let's look at a more advanced implementation of the decorator pattern. And we are going to create some extra data types here. But we are still going to create far less data types than we would if we were going the route of creating a data type for every combination of coffee. To start, we have a data type that's called beverage. It has a property called _cost, which is initialized as 0. And then there is a cost method on the prototype, which simply returns the value of _cost. Now, in terms of classical object-oriented programming languages, this would be considered an abstract class. It's a data type that we have created solely to inherit from. We wouldn't create instances of beverage. So for example, we could create a coffee data type that inherits from beverage. Inside of the coffee constructor, we need to call beverage and use the call method and then pass in this. And then we could go ahead and set the value of _cost to 5. But the main thing we need to do is chain the prototype. So coffee.prototype equals object.create, and then we will pass beverage.prototype. Now let's write a data type for our decorators, and we're going to create an abstract, quote-unquote, data type for our decorators. Now remember, a decorator needs to have the same interface as our objects. We're just adding extra functionality. But the same idea that we used in our simple implementation is going to be used within our prototypal implementation, in that we are going to have a beverage decorator, and its constructor is going to accept the beverage that we are decorating. So let's create this constructor function. We'll call it beverage decorator, and it will accept one argument, and that is the beverage that we want to decorate. This also needs to inherit beverage, so we'll go ahead and call beverage, passing this, and then we will create a property called a beverage that we will set to the beverage object passed to the constructor. Next, we need to set up the prototype inheritance. So beverage decorator.prototype equals object.create and beverage.prototype. But we also need another cost method here, because we want to take the cost of our decorator and add it to the cost of our beverage. So let's do beverage decorator.prototype.cost equals a function that is going to return this dot underscore cost plus this dot beverage dot cost. And I have a little syntax error there, so let me fix that. And now we have just about everything that we need to get started creating decorators for our coffee. So let's start with a data type called small. So function small. This needs to accept our beverage object, and this is a decorator, so it is going to call beverage decorator.call. We'll pass this as the first argument and beverage as the second argument. And then this underscore cost is going to be -1. We could do the same thing for large, except of course call it large, set cost to just 1, but then we also need to set up the prototype. So small.prototype equals object.create. And in this case, we want to use beverage decorator.prototype. And as I mentioned, we could do the same thing for large, but for the sake of brevity, let's just do one additive. We have one size, let's do one additive, and we will make this one sugar. So we'll call it sugar. It needs the beverage. We call beverage decorator. The cost we will say is 0.15, and then we simply need to set up the prototype chain. Sugar.prototype equals object.create, and passing in beverage decorator.prototype. So now if we wanted a small coffee with sugar, we would first of all create a coffee object. So we will new up coffee, and then we will take this coffee object equals new small, and we will pass in coffee. And to add sugar, we will do the same thing. New sugar, passing in coffee. So now let's test this in the browser. We started off at 5. By using the small decorator, we were at 4. And then by adding sugar, we added 0.15. So if we call coffee.cost, we should get 4.15. So the decorator pattern is one that allows us to add extra functionality to an object. But the key thing to remember is that it does not change the interface of that object.